Hello, today we are talking about antiderivatives, but specifically antiderivatives that include the power rule. So before we even get started with antiderivatives, I'd like to go through a quick refresher. So we have this refresher right here that says find dy dx. And again, if you look at all these, all the derivatives only involve the power rule. So in A, if I find dy dx, I'm going to get 4 times 2x plus 5, and the derivative of negative 2 is 0. And if I simplify that, that gives me 8x plus 5. Can you please pause the video and find the derivatives of the remaining 4 functions? Please pause the video here. So after finding each of these derivatives, I believe every single function has the exact same derivative, which is 8x plus 5. So let's move down into the box that talks about what an antiderivative is. And an antiderivative is really exactly what it sounds like. It's the undoing of a derivative. If you start with a derivative, or dy dx, then the blank will be the y you would have started with. Then the antiderivative would be the y you would have started with. So what I mean by that is, if we take the antiderivative of 8x plus 5, we should get one of these over here, the y I started with. Now, we're getting a little bit ahead of ourselves, so let's move on down to the you try 1. So in this one, if dy dx is 2x, what is y? I'm not asking you to pause the video, but I'm asking you to do this problem now, please. Okay, so we know that my derivative is 2x. So what did my function have to be to start with? Well, to get this 2 right here, I really should have had an exponent of 2. And my x here is really now raised to the first power. So if I were to have taken the derivative of x squared, let's just check, I should get 2x. Now, you try 2. Can you find another answer? And I'm asking you to write down another solution. And if off the top of your head you can't think of one, go back and look at that refresher that we did and see if you can come up with another solution. So another solution could have been something like 2x plus, hold on, let me check my refresher. I could have chosen 2x minus 2. I could have chosen 2x plus 3. I could have chosen 2x plus pi. But does it really matter what this number is here as far as getting from my function to my derivative? And I apologize, I just wrote down the derivative again. Let me fix what I have written again. My apologies. So what I mean is, if I had my function was x squared, I apologize, I was rewriting my derivative, I could have subtracted 2. I could have added 7. And again, it doesn't matter what this constant number is right here for right now, because as long as I know there could be a constant there, when I take the derivative of a constant, I get zeros. So in our next box, how many answers could we have? Well, I could sit here and write these all day long, which means I could have infinitely many solutions. The better question is, but how do we accommodate for that? After you write the antiderivative, add a plus c, okay? Because c could be any constant, and I don't know the specific constant that's supposed to be there, so I'm just going to say, there's a constant there. It could be 0. It could be negative a million. I don't know what that constant is, so I'm going to write plus c at the end. So if we move down to u try 3 now, which should look very familiar, if dy dx is 8x plus 5, what is y? And I want you to use this plus c notation. So please write down what y needs to be. So our y is going to be directly from our refresher. So we know this much, and again, from the refresher that we did, and then I'm going to add a plus c to the end, just so I know there could be a constant right here. So we're now right here. An antiderivative is an indefinite integral. And what was a definite integral? We did definite integrals the very first day, and that is actually the area under a curve. We were finding area with rectangles and triangles and sometimes trapezoids. But basically a definite integral, that's a number. Okay, you're going to get a numeric value, 172.5. This antiderivative is called an indefinite integral because we add that plus c. So I'm getting a function and I don't know what specific function it is. It's a general solution because it fits a family of solutions. So let's look now right here. If we start with dy dx is equal to x to the fifth, that can also be written as dy is equal to x to the fifth times dx. And what did I do exactly from my starting point here to get over here? Well, I multiplied both sides by dx. Now, you don't need to know that. I'm just telling you that's what happened. So when we do that, that sort of develops our notation for antiderivatives. So the biggest thing that you need to know is the integral symbol, which is this slanty S-looking thing. That's your integral symbol. So whenever you see that, what it is telling you to do, what the command is find the antiderivative. When you have this entire thing with the integral symbol, something in it, and a d something at the end, that's called the integral. So again, that's this whole thing is called the integral. The integrand, that's just the function that we're finding the antiderivative of, which is right there. And again, that's the integrand. Then we have this thing that's called the differential. That part isn't, we aren't going to use that word nearly as much as the other ones. And then finally, what's important about the differential is simply that variable right there. That's the variable that I'm integrating with respect to. Meaning when I took a derivative with respect to x, not say t. So let's look now at mathematical notation. This is the mathematical way to write the fact that the derivative and the indefinite integral are inverse operations. So let's look at what this says. G is the antiderivative of f if and only if the derivative of g is equal to f. So sit on that for a second to see if that makes sense. if you need another moment, pause the video. But basically what's happening is if I start with a derivative, and if you look down here, my derivative would be my g prime. If I, sorry, backwards. If I start with my antiderivative, then, if I start with my derivative, I'm not sure why I can't make this do what I want. If I start with my derivative, I'm trying to find the y. The derivative is f. When I find the antiderivative, I get g. When I take the derivative of that, I get f again. So this is this f over here. That means that my answer, which was this, for some reason I can't click today, that's my g. Sorry. Lots of lines everywhere. Okay, let's move on to the next page. How does the power rule work with antiderivatives? And let's investigate and see what happens. So number one, if I were to evaluate 3x squared, the integral of 3x squared dx, that means I took the derivative of something and I got 3x squared. So what did I have to start with? And what I needed to start with was x cubed. Double check that. If I do that derivative, do I get 3x squared? And I do. And then don't forget, it is an antiderivative or indefinite integral. I need that plus c. In the next one, I have the integral of 5x to the 4th dx. So x to the 5th is what I started with. And again, I had a plus c. Number 3, the integral of 6x to the 5th. And for that one, I think we're starting with x to the 6th plus c. And then we have, the integral of x cubed dx. I'm going to have to think about that one. Well, I know I would have started with an x to the 4th. That's the only way that I could get an x cubed. However, when I take the derivative, sorry, I'm doing a little scratch work over here. When I take that derivative, I get 4x to the 3rd. But my integrand doesn't have that 4. So how am I going to get rid of that 4? What if I had y is equal to 1/4 x to the 4? When I take that derivative, I would have 4 times 1/4 x cubed, and my 4 times 1/4 turns into a 1, and I do end up with x cubed. So this one needs a 1/4 in front plus c. Well, that one was a little tricky. But let's see if we can figure out what the rule is. Here is the rule for antiderivatives of polynomials, which simply means we're involved with the power rule of some sort. So if we look at this rule, let's see if we can make some sense of this. If we have the integral of x to the n, then that is going to be, I'm going to start here. Does it make sense that I'm adding 1 to my exponent? Well, when I take a derivative, I subtract 1 from my exponent. So actually that does make sense if I'm going backwards. I should be adding 1 to my exponent. And then I have this 1 over 1 plus my exponent. Coming back to the problem that we just did, where we had the integral of x cubed dx, let's see what we do. According to this is my n. My n is 3. So the answer should be 1 over 3 plus 1 times x to the 3 plus 1. And if I work that out, that is 1/4 x to the 4th plus c. So it does actually work. So let's try an example here. The integral of x to the 5th. So using my rule, it's going to be 1 over 5 plus 1, my n is 5, times x to the 5 plus 1, which is 6, plus c, and I would rewrite that as 1 over 6 x to the 6 plus c, which is absolutely fine if you write it as x to the 6th divided by 6. plus c. Those are the same thing. So let's look at example 2. So for example 2, we're evaluating the integral of x to the 4th dx. And again, my n is 4, so that's going to be 1 over 4 plus 1, which is 5, x raised to the 4 plus 1, which is 5, and then plus c. Again, if you want to write that as x to the 5th over 5 plus c, that is exactly the same thing. Now, this next one has a big, huge beware in front of it. And there's a reason for it. If you back up to the rule, I'm going to circle something in the rule, which you can barely see, n is not equal to 1. This rule does not work if n is equal to 1. Actually, it's supposed to be a negative 1. That's a typo. It's supposed to be a negative 1. Please fix that in the bubble. So if I evaluate this according to the power rule, let's just look and see what happens. I have x to the negative 1 dx, and then I work that out. My n is negative 1, so I have negative 1 plus 1 in the denominator. Do you see our problem? What happens in my denominator? I have a 0. I cannot have a 0 in my denominator, so that does not work. But let's see at what we do know. We learned a derivative of natural log of x. And when I take that derivative, I get 1 over x. Which means if I go backwards and I do the antiderivative of 1 over x, I should get natural log of x. So whenever you see just a 1 over x dx, that integral, that antiderivative, is going to be natural log of x plus c. I forgot my plus c over there. So please be aware of that one. Just keep your eye out for that one. Okay, so let's look at our properties now. Our properties of integrals are exactly the same as our properties for derivatives. If I have a constant, some number times a function, I am welcome to take that constant and pull it outside of the integral, deal with the antiderivative of my function, then multiply by that k when I'm finished. So I can deal with this in this manner, which means it's 7 times the antiderivative of x squared is 1 over 2 plus 1, 3, times x to the 2 plus 1, 3, plus c, or I can write it as 7/3 x cubed plus c. The sum and difference rule is the same again for derivatives. If I have two functions or two monomials, however you want to look at it, two terms that I'm adding together inside of an integral, I can break that into a single integral of the first term plus a single integral of the second term. So in this example, I can rewrite that. And I'm going to rewrite calculus friendly while I'm at it, and this in calculus friendly form is x raised to the 1/2. And at this point, I can find the antiderivative of each term. And again, be sure you're adding 1. So in this first term, it's going to be 1 over negative 3 plus 1. And that is a negative 2. X is now raised to the negative 2. That's negative 3 plus 1. Then I'm going to add my next one, which is 1 over 1 plus 1/2, which I believe is 3/2. And then x is raised to the 3/2. And then don't forget your plus c. So for the next one, again, we're going to do the same thing. We are going to rewrite this, and I'm going to write it calculus friendly as I go. So I have an integral of 2x to the negative 2, and I'm going to subtract the integral of x to the 1/3, and then I'm going to find the antiderivative of each one. I'm going to keep just going right below where I am. And again, this 2, what can I do with that 2? I can pull that 2 right outside, so I don't have to worry about it right here. So then I'm going to have 2, 1 over negative 2 plus 1 is negative 1, x raised to the negative 1, minus 1 over 3 plus 1 That's a 3 over 3, so that's 4/3, x to the 4/3 plus c. And again, I can simplify that if I wanted to, and if I simplified that, I'd have a negative 2 x to the negative 1 minus 3 over 4 x to the 4/3 plus c. And finally, we have one additional piece to this. We can also find the plus c if we're given enough information. And here's the extra information. So we have our derivative here, and we know that y is negative 7 when x is 1. So all I'm going to do for this problem is I'm going to do the indefinite integral of my dy dx. I'm going to split it apart, rewrite it calculus friendly, and pull any constants out front. So the first one, the constant, comes out. I need to rewrite this calculus friendly, and that is x to the 1/2. And then I have, if I pull my constant out, 6 is outside, x is inside my integral, and then I have minus 2, it doesn't matter where I put my integral sign, dx. So from here, I'm going to do it piece by piece. So my 3 stays along. I'm going to have 1 over 1 plus 1/2. We just did that, and that's 3/2. X will also be raised to the 3/2 plus 6. This n is actually 1, so I have 1 over 1 plus 1, which is 2, x to the 2, minus 2, and there's nothing really there. That means I had to have started with an x. So if I'm doing the antiderivative of a constant, that meant I started with the constant times x, and then I have my plus c. So now I can go ahead and plug things in. And this can be called y once I have found my antiderivative. I could have called this y the whole time if I would like to. I am going to simplify before I even start and write it non-calculus friendly. So when I have this, I really have 3 times 2 over 3, and happily what happens with those 3's is they make a silly version of the number 1, so I really just have a 2. And then I have the square root of x cubed, and I'm going to do probably the square root of x and then cube it would be my guess. And then I have plus 3x squared minus 2x plus c. So now I'm going to start plugging things in. I know that y is negative 7. So, sorry, one second. Y, sorry, undo. My negative 7 is going to be equal to, then I have 2 times the square root of my x. My x is 1, and that is being cubed. And then plus 3 times 1 squared, and then minus 2 times 1, and then I have this plus c. Sorry, that one should be green. I'm not sure why when I pick a different color it's not making it that color. Okay, so now I'm just going to work out my arithmetic with this. So I have negative 7 is going to be 2 plus 3 minus 2 plus c, and that tells me negative 7 is equal to 3 plus c, so c is equal to negative 10. And now I can rewrite my y. So my final answer will be my y is 2 square root of x cubed plus 3x squared minus 2x, and then instead of c, I'm going to write my actual c in there, which is minus 10. Please bring any questions you have with you to class, and have a wonderful evening.